Okay, so now that we have these formulas and they're often used to expand, you can also use these formulas in reverse and factor. And sometimes people, I think for these sorts of problems, rely a little less on the formulas and just sort of do their factoring slash expanding or their unfactoring, which would, I guess, be, you know, yeah, undistributing, unfoiling, which would be factoring. People kind of just do this staring at what they have instead of thinking purely in terms of formula, which I think, I guess here perhaps makes sense. Notice in this case, all three terms have an x squared as a factor, so we'll factor out x squared out of all three terms. Please be careful to make sure to have a plus one inside parentheses here. If you don't, sometimes people leave off this plus 1, then if you gave somebody x squared times the quantity x squared minus 13x, they're only going to get two terms. They're not going to get this plus x squared, this third term. So just to argue this in a little more detail, why that 1 is there, well, okay, so we just said what's incorrect about this, but the whole point is to really relate this and think as systematically and as consistently as we did for the middle term. So the reason that there's a 13x in the parentheses is because this answers x squared times what thing would equal 13x to the third. So for the same reason, 1 answers x squared times what equals x squared. It's got to be the same line of reasoning each time. We have to be consistent with this. And let's just keep in mind, if you're ever unsure about what's going on with your factoring, you can always check your work just by expanding your final answer and see if you end up with the original expression that was in the question to begin with. Okay, let's factor x squared plus 5x plus 6. This may look very peculiar. You'll probably skip this kind of line in the future. I know that I certainly do. I'm just trying to illustrate a point for right now that it looks peculiar, but you could write 5x as 2x plus 3x, and you can write 6 as 2 plus 3. This just looks a little bit more like than the FOIL formula just in reverse. Most of the time, people are going to jump directly from x squared plus 5x plus 6 to the x plus 3 times x plus 2 line. Don't work too much though. When we're talking about factoring, sometimes people do more than what the task is. The task was just a factor, and where that smiley face is, that's the end of the problem. Don't work too much. People sometimes work further and will take this x plus 3 times x plus 2. That's supposed to be the end of the work, and people often set this equal to 0. They'll create their own equation, and that's further work because, well, first of all, that's doing a different task. Okay, there's a certain kind of equation that can be solved after doing factoring, but there was no 0 in this problem, and please don't introduce one into the problem, right? So there's just the question was to take the original expression at the top and factor it. If you set this equal to 0, you're starting with an expressions problem and creating an equations problem. Another way that people create this equations problem is whether they write that set equal to 0 or not, then they end up with this x equals negative 3 as well as x equals negative 2. And again, those are equations. We started with an expression. So something's really off by doing this, right? So setting equal to 0 and then finally getting x equals negative 3 as well as x equals negative 2, that is for a different task. It's for solving a certain kind of equation that's for later in the semester, which has factoring as one step as part of the procedure. But let's not confuse the things together, right? Factoring is its own thing first, and then once we've mastered factoring, we can talk about how it gets used to solve a certain kind of equation. So for now, please just factor. The instructions in the question were just a factor, not to solve an equation. This really serves as just another reason to pay attention to the difference between expressions and equations. They're different things. There are different tasks surrounding them. The task here was to factor the expression x squared plus 5x plus 6. We were not asked to solve the equation x squared plus 5x plus 6 equals 0. Had we been asked to solve that equation, which we will not do yet, that will be in the future, then this business of setting x plus 3 times x plus 2 equal to 0 and writing things like x equals negative 3 and writing x equals negative 2, that will show up. But that's a later task, not now. Right now, we're just trying to talk about factoring. So don't I guess the point is you may be familiar with some other procedures which have factoring as one part of the recipe. Right now, you really got to stick to the task. The task is to factor. Okay, remember that an expression doesn't have an equal sign, though the work in between one expression and the next will have an equal sign. And remember that an expression is not solved, right? So, solved is a word that we will reserve for equations only. So let's factor x squared minus 25. This fits that difference of squares formula, so we'll have x plus 5 times x minus 5. Here's the thing: if you have no x term, right, not like a um, like the previous one, there would be like an x squared plus 5x plus 6, but there's no like 5x term here, right? So there's no middle term, right? Um, in this case, then you probably are going to apply the difference of squares formula. Let's factor 9p squared minus 49. Again, you actually have both the thing in front of the minus and after the minus. They both happen to be perfect squares, though this one, it might be easier to spot what the perfect squares are by first writing 9p squared as 3p quantity squared. And then the whole point is that this will turn into 3p plus 7 times 3p minus 7. If this doesn't look right to you, or you're kind of bothered by the work in the middle, this is just meant to really mimic the format of the true formula that's in the blue box. But you can check. You can take 3p plus 7 times 3p minus 7 and go through all the expanding and see if you get back 9p squared minus 49. Okay, interactive question. When you're done with any factoring task, how can you check your work? When providing your response, answer the question in a general sense first, and then explain how that applies to the question of factoring 9p squared minus 49 and the final answer of 3p plus 7 times 3p minus 7. I think I kind of gave that away in what I said, but that's okay. Just talk through that in your own words. Okay, let's factor x cubed plus 5x squared minus 14x. This one looks a little scarier because of the exponent for the x. Now, the highest exponent is a 3 instead of a 2. But you'll notice that all three terms have an x. So why don't we just factor out an x to start? And then look at x squared plus 5x minus 14 that's in parentheses. That can factor further. So that part, so copy the x, but then we'll factor the x squared plus 5x minus 14 as x plus 7 times x minus 2. Okay, so the whole point of this question is to say, please factor completely. Don't just stop after the first step of factoring. Once you factored, look at what you have. Look at the new pieces that you have, right? So what you originally started with doesn't look like the two pieces in the first step of the answer. I mean, I guess it looks like, but they're new pieces, and you should just examine each of the new pieces and ask yourself, do these factor anymore? Do these things factor? And so please be sure to factor completely. This question just on its own shows two kinds of factoring. Just to point out the two kinds of factoring we have mentioned earlier, that from the original expression to the first line of the answer, when you factor out x, that's undoing a variant of the distributive law, right? So that's undistributing. Whereas in the step that turned what was in parentheses in the first line of the answer into the thing with two sets of parentheses, this was undoing that FOIL type of expansion, right? So for me, these are really cognitively very different kinds of factoring. I tend to end up requiring, at least for myself, thinking about different things in order to do the two kinds of factoring, but somehow we use the word factoring for both of these tasks. By the way, in this second step, the x hadn't changed, right? It wasn't manipulated, it wasn't part of whatever, so we just had to copy it along. So those are the x in the first line of the answer and the x in the second line of the answer that are highlighted red, just to point out it had to be copied. And what did you do with it? What did we do with it? Nothing. We just copied it, and then what's left that's not in red, that we factored further. Okay, so after applying both types of factoring, x cubed plus 5x to the second minus 14x, we did it in two stages, right? But we applied in two stages the two kinds of factoring. We have now completely factored the original expression to be x times x plus 7 times x minus 2. Okay, let's factor 4x to the third minus 12x squared plus 5x minus 15. Now, when you are asked to factor an expression with four terms, you should consider factoring by grouping. This, I can't promise works all of the time, but every time you see four terms and you're asked to factor, you really ought to consider this factoring by grouping process. What you do is you factor what you can from the first two terms, that would be the first group, and then factor what you can from the second two terms or from the last two terms. Then examine the entire new expression and factor again if possible. So out of the first two terms, you can factor out a 4x squared. Out of the second two terms, you can factor out a 5. And now look, both there's a term in front of the plus sign and there's a term after the plus sign. Both of those terms have a factor of x minus 3, so let's factor that out. This x minus 3 is written outside a new set of parentheses, right? So in the new set of parentheses, you have 4x to the second plus 5. This looks funky. People are very often tempted to take the first line of the answer and instead say that their factoring is 4x to the second plus 5 then times x minus 3 quantity squared. The square that appears here is actually an error. I think people put the square here because they see x minus 3 here and x minus 3 there. But this is just not how factoring works. Whenever there was something common in two of the terms, you bring this out to only end up writing it once. Take a look at the shape of exactly a formula we're using. B plus C, quantity, times A, is BA plus CA, right? This is if you go from the left to the right, that would be expanding. We're going from right to left. And notice how there were two A's, right? There's an A in a yellow box and there's a second A in a yellow box. And then when you go back, there's just an A in a yellow box. It's not an A squared, it's just an A. Right? So BA plus CA turns into B plus C in parentheses times an A. So just doing the color highlights here, I hope this helps that the first line of the answer here, we've highlighted blue times yellow plus red times yellow turns into blue plus red in parentheses times yellow. There's no square. Yeah, just to highlight that again, the left side just has an A, not an A squared. If you would like to see this another way, let's clarify this by relating it to something we started this day's material with. So another way to see this, that there's no square here on the x minus 3, right? So putting a square is a mistake, that just the little 2 that's in red shouldn't be there. Let's, just to argue it, just to try to fully convince you, hopefully the colors did it in applying the formula on the previous slide. But another way to say this is, how about we just, for a moment, replace x minus 3 with a new variable called y. Then you'll have 4 times x cubed times y plus 5 times y. And then you can factor out from this new expression, factor out a y from both terms. In fact, earlier I asked you to star this. This should turn into 4x squared plus 5 in parentheses, then times a y outside parentheses. It's a y, not a y squared. And then, yeah, and if you're still uncertain about this, just think about if you took this y that's outside parentheses and distributed, you really would get 4x squared y plus 5y. If this said y squared outside parentheses, you'd get something else. Okay, now go ahead and replace the y, again, with an x minus 3. Earlier we replaced x minus 3 with a y, so now it makes sense to replace in reverse. Replace y with x minus 3, and so you have 4x squared plus 5 quantity times, and the y got replaced with x minus 3 in parentheses. Okay, notice again, this is an x minus 3, not an x minus 3 squared. That square would just magically appear out of nowhere and would be incorrect.